Rust is a constantly evolving language and a constantly evolving ecosystem, and you will have to be a bit passionate about it. I think that's very important. What we've observed at Nikulipe is that developers who want to work with Rust, they are really passionate and usually really good developers. They don't have a large choice of employers, so that's really a strong selling point for us to offer a 100% Rust code base. Different companies need different technologies, and there is no one true solution that everybody should go towards. That doesn't exist. So look at the constraints for your own project.
Hello everyone, and welcome back to another episode of the Rust interview series. Your Rust today is going to be myself, Luca Palmieri, the author of Zero to Production in Rust, as well as a principal engineering consultant for Mainmatter, the host of this series. Today we're joined by Florent Bécart. He is a CTO at Nikulipe, a payment processing company based in Lithuania, who's using Rust for some of their business processing. And we're going to learn more about that during the course of this interview. Welcome.
Hi, Luca. Thanks for having me here. Yeah, actually, we use Rust for all of our stack. So you said we use it for some of our services, but we are really fully on Rust. The company is a few years old today, and from the get-go, we went full on Rust. Yeah.
So before we dive deep into the details, let's get yourself acquainted with the people who are listening in. Do you mind introducing yourself?
So as you mentioned, I'm CTO Nikulipe. We are a fintech startup working in the payment industry, and we are based in Vilnius, Lithuania. So today I lead a team of 10 people, which is composed of software engineers and also infrastructure engineers. And personally, my background is in backend software engineering, initially in the Java technologies, but also in Node. And I've mostly worked in startups. I lived in multiple places, in Paris, in San Francisco, in Berlin, and now I'm based in Vilnius. I started with Rust in 2015. I was following the community, which at the time was really buzzing because the language was really in the making, and I was really attracted by the fact that it was the first low-level language that I felt was accessible to me, and how smart some of the choices were, for instance, about dealing with immutable or mutable data, how one structure can be used in both cases. It offered the type of engineering that initially with Java or Node was unreachable. For instance, operating system development, cryptography, rendering engines, and such. That's why Rust was so appealing to me.
I see. If I recall correctly from our warm-up conversation, although you were following Rust at the time, Nikulipe decided to use Rust before you joined them. And I'm curious about the background there. Like, what's the story, first and foremost, and what specific advantages does Rust bring to a payment startup such as Nikulipe?
So as you introduced us, we provide infrastructure for online payments. And the prerequisites for our services are high availability, scalability, resilience, and reliability. Like, we want as few bugs as possible. Our founders were previously very successful with C++, and they picked Rust because it had the same guarantees as C++, but it also added extra maintainability and safety. The fact that you have the borrow checker that provides, like, you have to manage memory, but at the same time, the compiler is really helping you not making mistakes. So it reduces the chances of introducing vulnerabilities through your code base. And it's a very pragmatic choice. If you look at the operations, the behavior of Rust in production is very predictable because there is no garbage collector. So it's fewer variables at runtime. Also, the services are very efficient and have a low footprint. And for us, it matters because we are self-hosted and we rent hardware and we run our own operating systems on them. And basically having fewer servers means reduced rental costs, but also reduced operations maintenance. The fact, of course, that Rust is open source and stable and well adopted by a large community, these were prerequisites for Rust adoption for Nikulipe.
I see. So you touched on some of the topics that are, I would say, often mentioned for people doing backend in Rust. So obviously there's safety, which when you're comparing it to C++ is a big element. You touched on performance and in particular on predictable performance, being able to see those P99s, P90s, P50s more or less behaving flat, giving a stable workload. Now, you are working on a payment system. I've worked on a payment system in the past, also worked written in Rust, incidentally. And one of the issues with payment systems is that the workload that comes as input is not necessarily stable in the sense that you may have spikes because of a big sport event or New Year's Eve or Christmas, where multiple people change their behavior and actually go and buy things, which results in a spike in payments. Does Rust provide any kind of benefits for the concurrency needs and the performance needs that are associated with handling such a spiky load?
Well, at the moment, we haven't had this kind of performance hurdles. We are monitoring the systems closely and we try to be proactive in identifying performance issues. From our observations, we consider that the biggest risk comes from our database, from Postgres. The fact that our Rust services are really low latency, our services are not doing a lot of computation. They don't use so much CPU at the moment. So really the biggest performance risk is on the database, on Postgres. And there we'll have, to be smart on how we organize our data, the indices we put in and the caches, etc. But so far, the Rust services seem to be efficient enough to not be a problem, which is great.
Let's shift focus slightly. So as you mentioned at the beginning, Nikulipe uses Rust for everything that they're doing, which includes the front end, which is somewhat unusual place for Rust to be, especially if you're not writing a application in the browser type of thing, like Photoshop in the browser, which is heavy on WebAssembly. And so I'm curious, first and foremost, what led you to Rust on the front end?
Well, I suppose all the developers were loving Rust and wanted more of Rust. What I can say is that having a code base in a single language is a great asset because it means there are fewer incentives for people to consider themselves front-enders or back-enders. It's really more like you can own an entire vertical of the stack and always talk in the same language. There is a lot of coherence between the front end, the HTTP APIs, and the backend services. Yeah, you interact with the entire system in a single language and you can share libraries in a smart way. Our front end is really like an administrative interface. We are a B2B company, so we didn't need any fancy front end, and it could as well have been a server-side rendered front end. To be honest, picking like a Rust server single-page application, it was a bit of a fantasy. Eventually, it's worked for us. We've had a lot of fun using Yew and using WebAssembly, and it works for our purpose, so we are very happy with it. I mentioned Yew, which is basically a port of React to Rust and WebAssembly. It's basically, behaving the same as React. It's just that the community support is not the same. So you have to do more on your own. And typically, we implemented our own components to be able to implement the backend, the interface that we needed.
So obviously you said, it's a less well-trodden path, which I think we can absolutely agree on. There's less people building front ends with Rust compared to JavaScript, probably a couple of orders of magnitude less people. You managed to get it to work for you, which is good to hear. So it can be done. But I guess my question, perhaps on the spicier side, is if you were starting from scratch today, right? So disregarding the cost of migrating the existing front-end stack to something else, which could be JavaScript, which could be something else, would you pick up, number one, Rust again for the front end, and would you pick up Yew?
Well, to be clear, we are not in this situation. We are not planning to switch away from Yew because really it works for them. The thing about front-end technologies is that they always come in trends and there is one framework today, and there will be a different framework tomorrow, and the technologies are changing, and the patterns are changing, and trying to follow these trends would be very costly, I believe, for a startup like us. Like, we need at some point to stick to our commitments. And especially when you have something that works, although it may not be perfect or it may have required some initial investment, you want to keep using it. So we prefer definitely to keep building with Yew than switching library for now. But if I had to make the decision, I think I would actually stick to the all Rust approach. It's really a great thing to have developers that have no excuse to not do front end. I really emphasize the fact that we have full stack engineers, which means that any engineer can work on a single vertical without being blocked by any part of the layer. So you should be able to touch the database, the services, the APIs, the documentation, the front end. Like, there is no excuse to be blocked by someone else. Basically, that's the approach here, and therefore having this one language for all the layers of the stack makes that more obvious and easy to accept for people who come from different cultures and companies. Now, in terms of which tool I would pick specifically, I actually don't know, because there are always, I think there are always new libraries, even in Rust, to do some front-end work. And I know that there are some very good ones now. And between you and these new ones, I don't know which one I would pick, because I would have to look into it, and I haven't done that work. Yeah.
No, that makes sense. Because my angle, and it's good to hear that you wouldn't switch, is if another company, is building their own stack in Rust, and there are probably a few, even among the listeners of this podcast, and they're using Rust on the back end, they're considering Rust on the front end, how much framework development or very deep framework knowledge do you think is necessary for somebody to unblock themselves if they choose Rust on the front end? So you mentioned that, the community is not as large, you're not going to find as many resources, you're not going to find as many threads explaining how to troubleshoot certain issues. So how much of Yew expertise did Nikulipe have to build to be able to make Yew work for whatever you needed to do?
Well, for us, there was one turning point. It's when we hired the developer who had previously mostly front-end experience with React, and he was really proactive in refactoring our front-end, taking ownership, and developing this new component library. Definitely, if you are in back-end mindset and you don't want to work too much on the front end, going with a framework like Yew may be the wrong choice, because actually you will have to spend time building that solution. For us, the fact that we have someone that is passionate about this and that has taken ownership, it really helped, because it's built, let's say, the internal library, the platform, which allows any other developer to quickly, easily implement the front ends they need. Yew was not an off-the-shelf solution where you can right away be efficient.
I see. So in a certain sense, he has set up the infrastructure, which then eases the other developers into doing the front-end tasks that they need to do on a daily basis. That makes sense. So we zoomed in on the front end, we zoomed in on Yew. Let's zoom out for a second, right? Nikulipe has been on Rust for a few years now. You have probably a non-trivial code base, but in terms of size and complexity. So you mentioned some of the advantages that you expected Rust to deliver. Now, my curiosity is, what challenges have you faced? Like, what things have you found to be obstacles in your Rust journey over the past few years at Nikulipe?
Well, one thing that comes to my mind is compile times. Of course, different developers come from different backgrounds and they will have different expectations. We have developers that have a background in C++, and for them, having long compile times is not a problem. But others come from Go or from PHP, and waiting a few minutes is way too long. And in general, waiting for compilation is a waste of time, in my opinion. So we are always trying to understand like how we could go faster, and we are a bit critical of the ecosystem when we find it suboptimal. Many things work and many things are fast, but also we see that the ecosystem is pushing for optimizing the compilation times. The limitations we see are, for instance, in Cargo. When Cargo tries to deal with larger workspaces, for instance, it's not helping as a linter to identify unused dependencies. It's also not able to optimize the features that are enabled, which means that often you used to implement the rusty workspace hack, which we've done. And also the level of caching by default, or even in general, it seems like even if you touch a unit test or a line of documentation, because your sources changed in a library, you invalidate the entire cache for the entire tree, and you will rebuild your entire workspace. In other languages and with other tools, I've seen that could be optimized by computing the checksums of outputs. And I would love to see something like this happening in Cargo workspaces, to be clear. And what affects compile times also is that we use Diesel as an ORM, and we have a fairly large database, which means it is costly in build times. That's another aspect. What we found is that we have actually ways to improve on our own. We are learning how to organize our workspace better, our sources better, to simplify the build tree and limit the amount of dependencies. You can also switch linker. We've experimented also with SC cache, although we've had mixed results because there are some limitations, like the incremental build that you cannot use when you enable SC cache. And we tracked the developments in the ecosystem, such as Crane Lift, which offers an alternative to the LLVM backend.
Have you actually tried Crane Lift for development? How did you find it?
Well, we are experimenting with it now, and we saw some benefits. Yeah, so we still need to do some tests before we roll it out for all the developers, but it's very promising.
For those who may not know what Crane Lift is an alternative backend for the Rust compiler that you can use instead of LLVM. It's designed to be much faster to generate artifacts, so it should complete compilation much sooner at the cost of degraded runtime performance. How degraded depends on what you're doing, and so that is a little bit, I think, what many folks, I assume also you, are playing around with. So trying to understand if the slowness in the compiled code makes it still viable, for example, to run tests, or if actually that's not fast enough and then you actually need to pay the full compilation cost. So that's also my own experiments with it for a little bit. I wouldn't say inconclusive, but difficult to decide if it was actually a boost, because the test ended up running a lot slower because of the different compilation backend.
Yeah, so it's very exciting to see this type of projects coming, because we are confident that Rust is evolving and evolving in the right direction for us, that the effort is put to, like, by various actors, various companies. A lot of energy is spent in improving the development experience. Yeah.
So you mentioned mostly compilation times and various shades of compilation times. Is there anything else that you currently find challenging in the ecosystem?
There is a little thing that has a big impact for us. It's been the capacity to work to have a very smooth experience working with Protobuf. What we've noticed is that, for instance, if you use Protobuf with Go, they work really well. Go and Protobuf together, and the Go types generated by Protobuf feel very native, and therefore you can describe your domain in Protobuf and then right away work with the generated types. That's a great experience. With Rust, we have trouble building types from Protobuf that feel Rust native. And as a result, we have patterns where we describe our domain also in Rust. So we duplicate a lot of the code just so that when we implement our core business logic, we can use the Rust types that we want. But that involves a lot of conversion from proto to domain, if that makes sense. We are looking for solutions here. What I would love to see personally is some way to annotate the proto definitions to indicate to Prost like the kind of Rust types we expect. So it would be similar to how SERDI behaves, where you can annotate your Rust structures to explain how to serialize and deserialize, for instance, from JSON. And here I imagine we could have something similar on proto definitions where we could say, oh, for this field, use this Rust type, for instance. This kind of small improvement. And it may sound like trivial, but actually it can have a very big impact on the productivity of development.
I've worked extensively on gRPC-based systems, and I've run into the same issues and deployed the same patterns when you basically have adapters into some domain level mapping on the type of things that you want to do. I guess one problem here is also that Protobuf works very nicely with Go in a way because it was designed for Go. And so a bunch of the semantics that Rust really needs, in particular, formalizing what is required and what is optional, is not available, at least in Protobuf 3, is only available in Protobuf 2. And the friction is a little bit into the format itself, as in like it doesn't square very nicely with the Rust type system. But obviously, we could probably do more to make that, mismatch less of an issue, I guess. Speaking of type systems, so you mentioned the type system a few times here and there throughout the answers we have heard so far. And I'm curious, what value is that producing for you? Like, where do you see the value in Rust type system in your day-to-day work?
For us, it means that we trust the code that is passing CI, basically. Once code has gone through Rusty and Clippy, it's already sound, and it simplifies the code review process. Basically, code review can focus on more important problems. And there are some really right choices in the type system of Rust compared to other ecosystems. So, for instance, the error handling is fantastic, or the fact that you won't have null pointer exceptions in Rust because the design is right. And what is really good with Rust is that a lot of the initial decisions were sane defaults. Like when you look at Rust code and it looks simple, it's usually actually better. It's going to perform better. It's going to be more sane. If you start having convoluted types, it's likely that you're going to have some inefficiency appearing, or the code is going to be incorrect even. The initial design choices of Rust make it easier to evaluate.
So, forward looking, what do you see the role of Rust and Nikulipe looking like a few years from now? Do you see that path compounding? Do you see different usage patterns? What's your prediction?
At Nikulipe, definitely Rust is here to stay. I've mentioned before that we are 100% in Rust from the beginning, and we don't plan to move for it because so far we are really well served. We want to keep growing our expertise internally and to capitalize on all the things we learn. Like I mentioned, to for instance, how our code architecture can influence build times, for instance. That's the kind of stuff we can learn to keep improving and keep having an excellent developer experience. And of course, we will keep monitoring the development of the ecosystems and improve our practices based on what we observe.
Cool. Now, let's step out for a second. In the audience, we probably have other decision makers, might be engineering managers, might be VP of engineering, might be other CTOs, or either starting to use Rust or evaluating Rust as a technology for their product suite or a part of their products. Now, as a fellow CTO, as a colleague, what kind of advice would you give these companies when navigating this decision? What kind of advice would you push forward as a person who's gone through the Rust journey?
Well, that's a great question. I would say first that different companies need different technologies, and there is no one true solution that everybody should go towards. That doesn't exist. So look at the constraints for your own project. Is it, for instance, a startup where you have to go really fast and you need to focus on speed of development, or do you have strong security considerations? Maybe it's latency you need to optimize for. So look at all these things. And also what technologies you know yourself. Rust is a constantly evolving language and a constantly evolving ecosystem. And you will have to be a bit passionate about it. I think that's very important. And if you just come as a guest and don't get involved into what's going on, I think you may run into problems compared to more established ecosystems where I can imagine, for instance, in the Java stack, you have Spring Framework, which has been there for decades now. And it's a great framework and it's very stable. Rust is excellent in a few key aspects. So, for instance, it has a very low footprint. The type system is excellent, and that has an impact on the maintainability of the code base. It's very secure, and also it has a premium support for WASM, which in WebAssembly will have a bigger and bigger impact on the ecosystem, on the industry. And finally, you can look at it from an HR perspective, what kind of people you want to hire, because the language you pick will influence who you hire. What we've observed at Nikulipe is that developers who want to work with Rust, they are really passionate and usually really good developers, and they don't have a large choice of employers. So that's really a strong selling point for us to be able to offer a 100% Rust code base. One thing you need to take into account is that not so many people have worked on large Rust projects, and the experience is different from a Hello World or a personal project. So you have to align expectations with the candidates.
Well, thanks a lot, Florent. That was a lot of questions. Sorry if I grilled you a little bit, but it's interesting to have a CTO to talk to about some of these themes, because we often get the perspective, obviously, of the individual contributors, the senior engineers, the mid-level engineers, but it's good to look at it from the eyes of somebody who's in charge of the technology strategy, fundamentally, for a company. Any closing remark that you want to share with our listeners before we wrap this up?
Well, thanks to all the contributors of the Rust ecosystem, like from the very beginning, and those who are also active today. Thank you to all of you.
And that's all for today. Thank you for listening in, and see you next time.